think about correlations, what we're really testing is what is the relationship between any two variables. So as an example, we might examine the relationship between someone's height and their weight. What we would expect is that probably as people's height increases, their weight is also going to increase on average. That doesn't mean that that's true for every single person in the population, but what it does indicate is a general trend in that data. And another example could be the amount of time spent studying with someone's exam score. Another example might be the level of extroversion someone has and the number of friends they have. So these are all examples of positive correlations. Whereas one variable increases, the other variable is also increasing. However, there might be a situation where we have a negative correlation. Think about something like temperature with enjoyment of ice cream. So as the temperature of the ice cream increases, you're probably going to enjoy that ice cream a little bit less as it increases over time. At least the average person. My wife's mom, she actually likes to microwave her ice cream before she eats it. But not everyone is like that. And what we see is that the general trend is that as ice cream temperature is increasing, the enjoyment of that ice cream is actually going to decrease. So here's an example of what these correlations look like. So what we always do is we plot the thing that's closest to our predictor. So maybe if we thought that height would be predictive of someone's weight, we would put height on the x-axis, we would put weight on the y-axis, and what we'd see is probably between those two variables a fairly strong correlation. Now, maybe a slightly weaker positive correlation might be, the level of extroversion and the number of friends somebody has. We're probably still expecting that it's going to be fairly strong relationship there, but it's probably not going to be quite as strong as the relationship between height and weight. So we've got a strong positive correlation here. We've got a weaker positive correlation here. Then similarly, as one variable increases, the other is decreasing here in this strong negative correlation graph. A little bit weaker where those dots are more spread out, the moderate correlation. And then we've also got no correlation, whereas one variable is increasing. The other variable is just kind of random and sporadic around that. And what we see is that generally our graphs don't actually look quite this perfect. A lot of times when I run correlational analyses, for running a power analysis, it usually says I need about 200 people to detect a moderate size correlation. And what we see here is there's only like 20 people being plotted in this graph. So actually the graphs look quite a bit messier than this, but this is a great indication of what these correlations are going to look like and what those general linear trends that we're looking for are going to have. So in this study, I was interested in examining people's enjoyment of ice cream depending on a few different factors. First is the amount of ice cream. What I'd expect is that a higher amount of ice cream or a greater amount of ice cream is going to be related to significantly higher enjoyment of that ice cream. The second thing I examined was perceptions of lack of flavor. What we would expect is that the more people perceive that there's a lack of flavor in their ice cream, the less they're going to enjoy that ice cream, so I'm predicting a negative correlation there. The next thing is the temperature of the ice cream. What I'm expecting is that as the temperature of my ice cream increases, participants are going to perceive that ice cream as less enjoyable. Again, I'm predicting a negative relationship there. So this is Jamovi, and what I need to do is I go up to regression correlation matrix. This is going to test the relationships between all of those variables at the same time. So the thing that I'm really interested in is the enjoyment of ice cream. So I like to put that first. That's kind of, you can think of this almost like the outcome variable, that I believe all of these other things are going to contribute to that outcome. So then I'm going to put in the amount of ice cream, the lack of flavor of the ice cream, and the temperature of the ice cream. And the way that I clicked all of those at once was I just held down the control button and I clicked. So we can move all of those over to the right side here. Already you can see that the correlations are being presented, but I'm going to go ahead and flag significant correlations there. Now, with our correlations, you could, because I came into this expecting that, amount of ice cream is going to be correlated with greater enjoyment, I could make a hypothesis that those two things are correlated positively, in which case I would run a one-tailed test instead of a two-tailed test. But most of the time I see people reporting two-tailed tests. That's what I'm going to suggest to you, unless there is some theoretical rationale and you've pre-registered your study. By the way, keep an eye out. I'm going to make a video very soon on pre-registering studies within psychology. But coming back to this, again, what I'm predicting is that the enjoyment of ice cream is going to be positively related to the amount of ice cream that they're given, is going to be negatively related to the lack of flavor of that ice cream, and is going to be negatively related to the temperature of the ice cream. So over here are the correlations. The first value that it presents each time is the R value. This value can take on any value from -1 to +1. So the closer to 0 that these numbers get, the weaker the correlation. So the more it indicates that there's nothing going on between those two variables. The closer to 1 in either direction, so the closer to -1, the closer to +1, the more that this indicates an actual correlation is happening, and it's a stronger correlation. So that R value is telling you the direction and the strength of the correlation. And again, that can be anything between -1 and +1. Generally, in psychology, we start to get a little bit excited when the correlation goes above about 0.20. A pretty moderate to strong correlation is going to be about 0.30, and then a pretty darn strong correlation is going to be above 0.40. And so what we're seeing here, what's happening is this actually plots the variables on the left side as well as across the top. And so you can see this is enjoyment of ice cream in both of these spots. This is amount of ice cream in both of these spots. This is lack of flavor of the ice cream in both of these spots. And then we've got temperature of ice cream in both of those spots. So the reason that it doesn't give us any numbers on this diagonal is because that's just each variable with itself. So you've got enjoyment of ice cream correlated with enjoyment of ice cream. Nothing to correlate there. The correlation would be exactly 1.00. And so there's no reason to plot that there. Additionally, the reason that it's not giving us anything above the diagonal is because this would just be a mirrored image of what's below the diagonal. So this one right here would be 0.45 because that is the amount of ice cream correlated with the enjoyment of ice cream, which would go there. That's the exact same as this. So enjoyment of ice cream with the amount of ice cream, and we see that that correlation is 0.45. And we also see that that is significant because that p-value is less than 0.05. Coming down here, and that's consistent with my hypotheses. So the conclusion that I would write here is that greater enjoyment of ice cream was related positively to the amount of ice cream. Or in other words, what I should really say there, because I'm actually predicting that amount of ice cream is going to be my predictor and enjoyment of ice cream is going to be my outcome, I would actually flip those. So what I might say is that consistent with my hypotheses, a greater amount of ice cream is positively related to enjoyment of ice cream. Now, also consistent with my hypotheses, what I found is that lack of flavor of the ice cream was negatively correlated with the enjoyment of the ice cream. So the more that that ice cream lacked flavor, the less enjoyable participants perceived that ice cream to be. And then finally, we have the temperature of the ice cream with enjoyment of ice cream. And what we're seeing is that that is a negative relationship such that as temperature of the ice cream increased, participants enjoyed that ice cream significantly less. Now, you'll notice that I didn't really talk about these correlations over here. That doesn't mean that they're not important. It's just they're there if anyone wants to see them. So when I actually report these values, I would probably make what's called a correlation table, which, by the way, keep an eye out for that video, and I'm going to link it in the comments as well for this video. But generally, I don't talk about every single correlation in these tables. The reason being is because I will present them so my reader, if they're really interested in those correlations, they can check it out. But really, I'm not that interested in how the amount of ice cream correlates with the lack of flavor. There's nothing really that's interesting to me in those analyses. And so really, I'm more interested in just this column, how each of these predictors affects this continuous variable of enjoyment of ice cream. Now we do want to be careful. I did use the word affects. That's because I'm predicting that those things are leading to the enjoyment of ice cream. However, as you might have heard in previous classes or in previous videos, correlation does not equal causation. That's because we don't know which came first. So is it that enjoyment of ice cream is coming first and that's why people are having a higher amount of ice cream? We don't know. And also that there could be some third variable that's actually influencing both of these. Do people, when they know that they're going to like the ice, so if it's a flavor that they like more, do they automatically reach for more ice cream? And is that actually what's causing these relationships? Or is it something else? So now if I want to report these findings, and again, we would already have a correlation table made and in our manuscript or in our results section, which by the way, again, I'm going to link to how to make those tables below. What we would then say in the actual results section when we write about these findings, I might say something like, consistent with my hypotheses, I found that the amount of ice cream consumed was positively related to participants' enjoyment of the ice cream. Further, and consistent with my hypotheses, warmer temperatures and the more that participants perceived the ice cream as lacking flavor were associated with significantly lower enjoyment of the ice cream. So what I'm doing there is I'm not presenting participants with things that are beside the point. I'm focusing in primarily just on the testing of my hypotheses. And not only that, I'm telling them whether it's consistent or not very clearly in reporting these. And then what I would also do is I would want to then kind of make a general statement to conclude these analyses. So that's what I have on running correlations and in Jamovi. If you have any questions or if you'd like to see a video, please let me know what you'd like me to do. And as always, make sure to hit that like and subscribe button and be on the lookout for other videos coming out.